Good afternoon, everyone. I hope all of you have joined. I am Jobasmita Sharma, the Human Resource and Administration Representative of Digital Institute of Technology. We are delighted to have you join us today for this special webinar, where we will be introducing our exclusive services and offering discounted prices on all our courses, with a focus on our inaugural courses, Data Analytics. Digital Institute of Technology is a premier computer training institute that offers both professional and certificate courses. We are committed to providing the best education to our students, fostering teamwork, and dedicating ourselves to meeting every student's expectations. With our corporate office located in Guwahati, Assam, and a branch office in Dhanbad, Jharkhand, we offer a diverse range of courses, including ethical hacking, cyber forensics, bug bounty, machine learning, artificial intelligence, digital marketing, postgraduate diploma certificate, ADCA, Tele, graphics design, web and software development, and various crash courses. Today, we are honored to have with us our data analytics expert, Mr. Devjyoti Panda. With 4 years of professional experience as a data scientist, Mr. Panda is not only expert in data analysis but also proficient in machine learning, statistical analysis, and programming language such as Python, Apex, and data manipulations. He is skilled in data collection, cleaning, and analysis to uncover valuable pattern and trend. Without further ado, I would like to hand over the session to Mr. Panda, who will share his knowledge and expertise with us. Please join me in welcoming him. Mr. Devjyoti Panda, are you there?
Yeah. Thanks, Reva. Am I audible?
Yeah, you are audible.
Yeah.
So I am handing over the session to you. The session is yours now.
Yeah. Thanks. Sure. Hi, everyone. Good evening. And as Jova is already, introduced, but I still want to, deliver some sort of lines for introduce myself. So I'm Debjyoti, and I have 4+ years of experience as a data scientist, and not only in specific to data scientist, but of as well I have 1.5+ years of experience in Salesforce as well. That that's world's largest CRM. And before jumping to this webinar, just or you can say that we just discuss about this. What is data and what are the types of data that is present, and like what are the roles and responsibilities in data engineering present. All of you might hear some terminologies like we are working, some of your friends are working as a data analyst, some of them are working as a data engineer, and some of them are working as a data scientist. So what this role basically defines, what are the responsibilities that for that it is bifurcated in some sort of roles, and what are the databases, what is this called by data warehouse. And like we see normally a lot of charts, like for let's example line graph, bar chart, or some sort of histogram. So how to create them, and what are the jobs that is available in for the data analyst. And we'll just lastly go to this one kind of interesting project that defines as an end-to-end perspective, that how to start this in a data analysis, and what are the end goals of that. So I just quickly share my screen. Just a second. Is it visible? Is my
Is my
screen up?
screen
Can
up?
anyone
Can anyone
confirm?
confirm? Yes,
Yes,
it's
it's
visible.
visible.
Yeah, yeah. Thanks for
Yeah,
confirming.
it's visible.
Thanks. So as I already have mentioned that we'll be just jumping to this data and data life cycle. What are the types of data, roles and responsibilities, and this quality measures, domains, and introduction to this database data warehouse, collection methodologies, best practices for that, charts in Python, and what are the jobs that is present into this data analysis or data analysis we call as a data analyst as a role. And last we'll talk about one project, specific interesting project for that. Okay. So before jumping to this webinar, I just want to hear out from you guys that what you understand by data. जब हम लोग data term सुनते हो तब लोग के दिमाग में पहले क्या thoughts आते हैं? What it means? Can anyone explain? Your answer might be wrong, but आप बता सकते हैं कोई प्रॉब्लम नहीं है.
Data is the useful information, maybe.
Mm-hmm. Anyone else? Okay.
Dipti,
Yeah.
uh, हेलो.
Yes, you are audible.
हाँ, तो मैं सुन रहा था एक्चुअली मेरा पास कोई मैसेज कर रहा था हमको कि मतलब हिंदी में भी मतलब वो करने के लिए बोले. तो एक बार सब लोग कंफर्म करो कि मतलब हिंदी में किसको चाहिए मतलब इंग्लिश में किसको चाहिए, क्योंकि यहाँ पे क्या हुआ है कि बाहर से भी मतलब इंडिया से बाहर से भी मतलब कोई रेस
Okay.
हुआ है.
हाँ, no
तो
problem.
एक बार हाँ.
So मैं हिंदी में कंटिन्यू करूं कि आप मतलब सुनना चाहते हैं सबसे कि सब लोग क्या बोल रहे हैं?
No, Devjyoti, you can continue in English itself. The complete session will be in English. Yeah.
Okay. Perfect. No problem. Okay, so just I was discussing about the data. That what is data? So as you know that we normally in day-to-day life we generate a lot of data, and the perfect example should be, let's example you are going out in a weekend, right? So you just carry your phone, might be you'll go to a place, chill, and then you take some sort of photos, videos, and all. So taking photos, taking videos is nothing but you are storing data in your smartphone. And apart from that, like we generate data in multiple factors. One example I already have given you, and apart from that, if you are writing any notes in your phone or laptop, or might be you are creating one account in Facebook or Instagram, anything like that. So that is nothing but you are generating data, and you might be wonder to hear out that the estimated 90% of world's data that was generated in last 2 years. Okay, so that is what actually, and data actually is present in multiple ways, like, or multiple factors. So one could be in an unstructural form, one could be in a form of structural form. So what is the structural and unstructural form, that we'll definitely discuss later, but give you a quick hint about it. Structural data is nothing which is present in a form of tabular or in a kind of structural form. So as an example, let's assume you are creating one study timeline. So you have written from 10 a.m. to 12 a.m. 10 a.m. to 12 p.m. you will be studying about statistics. Same 2 p.m. to 4 p.m. you will be studying about machine learning, and 4 p.m. to 6 p.m. you will be studying about deep learning. Let's example. So this is something you are storing, or you are creating in a structural way. So that is how it is called as a structural data. And apart from that, talking about unstructured data, uh, as I already have given you example, like if you capture one video, or you see a lot of CCTVs is present into different malls or outside of any kind of homes. So the video that has been captured by the CCTV, or the images that has been captured by your phone or CCTV, that is present in a sort of unstructured form, that we'll definitely discuss in a detailed form in the upcoming slides. But to give you this hint that most of data on world's most of data is is in a form of dirty way, you can say, or in a form of unstructured way. So we first have to, as a data engineer or as a data analyst or data scientist, whatever you say, we firstly have to collect the data in a form of raw data, we'll say. where the data will not stored in a particularly way, and there could be multiple null values, missing values that is present into the data set. So you firstly have to collect the data, you have to sort it accordingly, and you have to arrange. You can refer to this right side image that is present, how data is formed in a a raw format or in a dirty format, and after storing how it is looking like. As you can see, it is it has been sorted by the colors. So the black is at the left side, and after that yellow and white, blue and the reds, that's how it is sorted by these colors. And after arranged, it is looking like that. And whenever we'll visually present the data, it will look like this, whatever you can see in this second last image. And one most important factor whenever you are working as a data engineer, you have to think of it that it is not only to create charts or visualization at end, but of you need to find one story into the data. So like given you one example, if you're working for a client, let's example the client wants to know that uh, you might be hear about this Dubai case, how Dubai has gone for this flood things. So how these things happened actually. If you are data engineer, I'll be giving you one data set that contains multiple columns. One is for humidity, one tells about this how much pressure for that area was, sunshine, sunset timings, and different kind of things. So as a data engineer, it's not your job only to create graphs by picking two or three data points. Like I pick one factor called as atmosphere, I pick one factor called as sunset time, and then I'll make one plot. So that doesn't make any sense, right? So you have to think of that what are the related factors that is present into the data set, and you have to pick these two or multiple data points, I can say data points respectively, and then to create plots based on that. And most importantly, what I mean by explained with a story, at last you should come up with some sort of story that actually portrays this whole thing. So if I'm looking that why this Dubai faces flood things in last some months, so you will have a different data columns present into the data set, and the different plots will say a different story, and all the stories will be clubbed together and create one full story. So you can say that humidity, by changing the pressure of the area, can cause high rainfall, same as changing this due to the lack of sunrises for a couple of days m- might create one some sort of points to for this flood. So that's why how we normally portray story as a data engineer. I'll give you a better scenario after some couple of slides. Actually, I have one specific data set to explain you guys. So apart from that, I can say that data is nothing but it's a collection of raw facts or figures. It's called data. And data could be in a form of numbers, characters, graphs, and like and data is actually categorized into different things like in a form categorical and continuous, that we'll discuss in this next slide. So do you have any confusion guys for this slide, or should I go to the next one?
चलो इतना तो
Devjyoti, we can have a Q&A session at last for the 15 minutes.
Okay, sure,
Then
sure. Yeah, sure. So now we'll talk about this data life cycle. As you know that we have 7 individual points for that. So what data life cycle defines, I'll tell you. So whenever you, as a data engineer, you'll be working for a client, you have to follow some basic points to work for this. So first will be your business understanding. So it will not like that I'll collect data from client and I'll not have any kind of discussion with client, and directly I import the data and I'll start working into it. That shouldn't be there. But of you have to think about that what the exactly requirement of client, what clients wants to get from the data, whatever they are providing it to you. So before looking into the data, or after looking into the overall looking into the data, you should have two or two, 3 rounds of discussion with the client, that what are their exact requirements for that, and what they're looking for at end. That comes for this business understanding. Okay. And like for second is talking about data mining. So data mining is nothing but data collection and data mining are same, where you will just collect the data from different sources. So in some of cases client will directly provide you the data. In some sort of cases you have to collect the data that could be present in different places. So looking for the sales data, you have to find some areas where the sales data is present, and looking for this medical industries data, you have to look for this data for medical industries. That comes under this data collection methodologies that we'll definitely discuss later. But you can say in a way that data collection is nothing but how normally data engineer collect the data, way of collecting data. Okay, so third point comes for this data cleaning and pre-processing. So data cleaning is something that whenever we'll get the data 95 to 98% of data is in a raw format or unclean format, or you can say in a dirty format, where like there is a lot of missing values, there is a lot of duplicate values that is present into the data, right? So let's example, you have given one data set that contains student data for a particularly school. So you can see there is a 30 students of data has been enrolled for that, and like for almost 4 to 5 students of data is missing in from the data set, right? So you have to either you have to delete the data for this respectively 5 students that is not present, or if the data is important, then you have to look for the other factors that how to replace the data with with some another data. And there is a different kind of methods present for it. You can also get the mean for the other for the different for the same column that is present into it, and you can replace with that. So that is one thing as a data cleaning and processing. And whenever we will be done with that, we'll go for this EDA part. What is EDA? EDA is nothing but exploratory data analysis, where you will perform some charts or visualization based on that, right? So like let's example, in the student data set you will have columns as student name, grade, section, and height, weight, gender, etc. So if you have to perform some exploratory data analysis, it's not like that I pick one student name column, and like for student name is actually validable. Like, let's example student weight and attendance. So there is no relation between student weight and attendance. So you have to actually think for that what are the columns that is related to each other. So if I make a plot for student height and student weight, that is a relevant plot. So exploratory data analysis means that from these relevant data points, how you are making this graphs and plots based on that, right? So that comes for this exploratory data analysis. And whenever you are done with ADA, then we'll jump into this machine learning model. So machine learning model normally used to get the predictions for this. Why we need prediction? We need prediction because of for this data set. Let's example, you have 1000 rows in your data set that is present. So we'll create one machine learning model, and in future if you get the new data from any sources, you will not repeat all the steps you have done earlier, but of you will have one dedicated trained model into it, and by feeding the new data into ML model, it will give you the corresponding output based on that, right? This is how this ML model will work. I'll definitely explain this in a better way in this next slide. I mean, in some next slide, I guess. And whenever we're done for this all of the things, then we have to interpret the results using dashboards or charts, because of end goal is to send these charts to vice president or senior vice president for any kind of companies that is present, right? So this whole things portrays this data life cycle for this. And talking for the next slide, that is types of data, where we have two different types of data present. One is qualitative, one is quantitative. So what is qualitative data means that is also bifurcated into two categories, that is nominal and ordinal, and for quantitative data that is bifurcated into two, that is discrete and continuous. So talking about qualitative data, that is nothing but of cannot be counted or measured or expressed using numbers. So let's example hair color of any specific person. So you could have different answer for that, either black, white, gray, or some sort of things like. So this kind of data comes under this nominal, and for ordinal, that is some sort of things like if I ask you like that what are the if I tell you to get this ranking for students that is present into class, that comes under this ordinal. Okay, because like you will give me a list, either that should be in a form of ascending or descending order, that comes to this ordinal. And you can see these examples for ordinal, that is data taken from a poll or survey. So you can take example for uh, vote, like for voting and all. So how this vote polls results come out, that comes into this ordinal data. And talking about quantitative data, where this will get values or counts that are expressed in numbers, right? So talking about numbers, we have two different numbers is present. One is discrete, one is continuous. Discrete is something that is non-divisible figures, because if I ask you that how many of you present into this call, so your answer should be either 10, 20, 30, something like that. You will not say that we are the 10.5 people present into this call. That is not possible, right? That is how this discrete means. And talking about continuous data, like where we have as a continuous output, like if I ask you that what is the temperature for today, so there is no fixed temperature for today, because as we all know that this minimum temperature goes in midnight, and max temperature goes in this afternoon time. So your answer should be today's temperature is 26 degree to let's example 36 degrees Celsius. So that is how this continuous means. Or if anyone asks you that let's example one Tata car will be about to launch in 2 months, so if I ask you that what could be the price of this car, so we'll share that the price of the car should be from 20 to 25 lakhs. That is the example for continuous data, right? So going to the next slide, that is different type of data. I already have explained this. You can see in this left figure, we have two kind of data. One is unstructured data and one is structured data. Unstructured data is also categorized in three categories, that is log data, text data, or unstructured images. Unstructured means which is not stored in a particularly format, right? So that is something unstructured. Video, audio, image, text, log, everything is present, everything comes under this unstructured data. Talking about structured data, which is formed in a properly structure, and that is also categorized into two, that is categorical and numeric. Categorical is what, where we have some sort of boolean output into it. Let's example gender, that could be male, female, or other. Or if I give you some example to select for this, that what is the probability of rainfall for tomorrow, so you'll either answer me that yes, there is a probability of rainfall, or you'll give me this there is no probability for rainfall. Or third answer could be there is a maybe, like for might be there is a chance for rainfall for tomorrow. That comes under this categorical. Talking about numeric, we also have two values. One is discrete and continuous, that I already have explained. Discrete is something that is non-divisible, and continuous something that we get the output in a continuous form. So giving example for discrete, that how many times I flip head. So whenever we'll toss any coin, then there is a probability of getting heads or tails. It is not this into this scenario of tossing any coin. You will have only two scenario, either head or tail. There is not any third one, right? So that comes into this discrete. And continuous is where we'll get the output in a range or in a continuous format. That comes into this uh, continuous values. And talking about big data, that is basically a large topic to explain, but I'll give you short background of it. We normally use three ways for to describe this big data. One V indicates volume, and second V velocity, and third V goes for variety. So what is the volume? Volume is this how much amount of data has been generated, because of as this terminology defines what you mean by big data. That is nothing where we have a large amount of data present into it. Like so and velocity is something that actually explains that what is the speed of generating data, and that could be also in the form of online and offline as well. And variety is something that what are the types of data is present into it, that could be different things. I already have added structured and unstructured, and there is one more category that could be also present into it, that is semi-structured. Semi-structured is something that could be in a present of structural way as well and non-structural format as well. So if I give you example now, we already mail someone in day-to-day life. You all have mail, and you can see that there is a lot of emails come to a phone, right? So mail comes to semi-structured category actually, because of when I send you mail now, I can also add one table into it, or I can add as well photo or video into the mail. So if I send you a mail only writing some like some sort of things like my name, phone number, address, and other things into it, so that comes under this structural way. But if I attach one video into my mail and if I send it to you, that comes under this unstructured way. So that is why the mail is called as a semi-structured data. So variety is something that how much of types of data into present into it. So this is the majorly 3V stands for big data, right? So I have one exercise for you guys, but that will discuss in this post this, whenever I'll just finish this slide after that. So you will be given two scenario, and you have to tell me that among this scenario, that what type of data that is actually, either that is a you know discrete data, that is a continuous data, or that is a forms comes under this unstructured data, right? So I'll go to the next slide, that is data roles and responsibilities. So as I already have explaining you that we had a lot of terminologies in this data engineering field, that some of our friend is working as data scientist, some of them is working as a data engineer, and some of them is working as a data analyst, or you can say an analytics engineer. So basically what defines them into different roles, that is the most important thing. So if I share that what basically a data analyst do, data analysts do one thing. They normally collect the data from client's end, and then they will look into the data. If there is any kind of raw format into it, if there is a lot of null values and missing values, they deal with that. They will clean the data set, and they'll pass it to the data engineer, right? And what data engineer do, data engineer normally build the pipeline. What do you mean by pipeline? Pipeline is basically a streaming platform where you can, if I give you a simple example for that, it's basically a process that runs 24/7 and gives us a output. So what is it like? If you log into Facebook, so you can see that if I want to create one, let's take an example for creating one Facebook account. So if I want to create one Facebook account, might be I can able to create at midnight as well, or anytime if I want. So there is no scheduled time for it, that only if I want to create one account in Facebook, I have to log in from 7 p.m. to 9 p.m. in between that. Because of there is a process, like if I'm inputting my Gmail and password into it, so that is feeding my mail and password into it and gives me a corresponding user ID. So from the next time onwards, if I want to log in, I can put these things and I can log in respectively, right? So because of there is a pipeline, or you can say a batch job into the pipeline, that is streaming 24/7 into the backend. So that is primary responsibility for a data engineer who will handle it, right? And there is a lot of things that is present into this pipeline. So that will discuss in a different session. But talking about this data scientists normally deal with this machine learning things, like to creating models, deploy the models, and building different models, as well as to compare different models. So in, let's example, in one model I'll get accuracy of 70%, or in a different model I'll get accuracy of 85%. So I have to compare between them, that what are the best accuracy of model, and I'll just have to deploy them respectively at the end. That is how this things is categorized, right? So yeah, so talking about data analytics, I already have explained that is a process of examining data sets in order to draw conclusions about the information they contain and use to enhance productivity and business gain, right? And the scope is very limited to structured data. Why data analytics scope is limited to structured data? Because we have two supported language in this industry to work on. One is Python, second is R. So whatever language you choose, so the your very first step will be to pull the data set into your notebook. Notebook is some sort of environment where you normally do coding in day-to-day life, right? So first of all, you pull the data set into a notebook, and then you have to look into it, that is there any kind of null values or repeated values or duplicate values, whatever I've explained, the steps will be repeating. But it is only limited to structural data, because I can't really pull a video or pull an image to look into it. That is not possible into Jupyter notebook or any kind of notebook you are using for that, right? So that is why it is written here that the scope is very limited to structural data, right? So that is something for this data analytics, where we have different kind of things integrating into it. One is computer science, maths and statistics, because of it doesn't count that you are working as a data analyst or data engineer or data scientist, but you have to work for a lot of maths and statistics into it, because of you have to you know uh, to be a proper knowledge on like for statistical areas. So give an example, like for histogram, mean, median, mode, and what I can say, like for distribution for this, and so on and so on. So maths and statistics is very much important for that. And the major things is this domain expertise. So, what is basically this domain expertise? So domain expertise is something, if I'm working as a data analyst into a medical industry, and you guys are working and as a also a data analyst in a different sector, that could be in a finance domain or in a banking domain, I can say. So I'm working in a sales domain and you are working as a medical domain. So although our technical skills is very much of high, I can say, but still if I go to this medical sector, I'll not boom in that area, because of I do have technical expertise based on that, but domain knowledge is also very much of important in that area. Because if a data analyst jump to the different domain now, you have to spend a lot of time based on that to understand that what are the root terminologies used in that specific area, and what are the sub key factors that is present into it. That is very much of important. So this point normally everyone skips for this domain expertise, but I want you guys to highlight for this thing specifically, because domain expertise is something you have to have to get a proper knowledge about it. Otherwise, it doesn't count that how much technical knowledge you do have. You can't really boom into that. So that is how actually you have to spend a lot of time for this specific domain to work on, right? So this is some sort of terminologies that is present into this data analytics. And in the next slides, that defines that what is this data science, or what are the data scientists do in a day-to-day life. So as I already mentioned, that data scientist is more towards this machine learning model and building, and then to compare them with different models to deploy them at last and everything. This photo might be hazy, but I just verbally explaining that will be better. So here it is written that what are the important to become a modern data scientist. That is, you have to get a proper knowledge for math and scientist. I mean, sorry, math and statistics, and you have to get a domain knowledge for that. Soft skills as well very much of important, because if you are a good technical skill but you are unable to speak in front of client, so whatever the what I can say, like if you have some couple of doubts that you are not able to tell the client that these are the doubts that I do have for this specific data set, but if you are conducting meeting for back to back but you are not pretty clear with the data set, that also doesn't count. So you have to just you know go for this point for soft skill as well. And apart from that, programming knowledge and database knowledge as well. So what is programming knowledge? As I already have explained, that we'll have two options to boost up your knowledge. One is for learning Python or R. our language based on that. And in the database knowledge, it's better to have two databases knowledge. One is for structural databases knowledge, one is for unstructured databases knowledge. So what is this structural databases where structural data has been stored, and what is this unstructured databases where unstructured data has been stored? Like, you can say that your mobile device storage is some sort of unstructured data storage where you can able to store this, you know, photos, videos, and all. Although your phone storage is not considered as a database, but still it's a, some sort of tiny example to explain you in a better way, right? And communication and visualization is also a key factors into it, where you have to uh, get a clear understanding of that why in which time you have to use what kind of plots for that area, right? And communication is always, I already have explained you that you have to get this knowledge, because of otherwise you'll be unavailable to unable to connect with client to get the specific requirement for that, right? And what is written is a data science. So data science is a field about processes and systems to extract data from various forms, whether it is unstructured or unstructured, right? And it is a study for both structured and unstructured data, and it involves using these automated methods to analyze massive amounts of data to extract knowledge from them, right? So this is something for data science and responsibilities for that. And here in this slide, I have bifurcated them, like for what this data engineer especially do, and what is the data analyst do, and what are the data scientists do. So although it has been bifurcated in that area, but whenever you are working in an industry specific now, in somehow you have to handle it in end-to-end basis. Like, I'll not say in that way, if you are a data scientist, then you don't have to work for this data cleaning, because it doesn't count that whatever your roles and responsibilities are, but you have to get a clear understanding of everything. Like, for if I'm a data scientist, I know that how to build a machine learning model, I should have knowledge as well to clean the data or to understand the data as well, right? Sure, but this key major differentiation is already written here, that what is a data engineer, analyst, and scientist do. I'll go for the points. So as a data engineer, firstly invest and store data, and they normally set up the databases and data warehouse structures, maintain the databases and data structure. They build data pipelines, as I have mentioned, and there's a strong database related software skills. We're talking about the data analyst. They identify the patterns in data, they access the databases, they use the output of pipelines built by data engineers, right? So they create visualizations for better presenting data and the strong dashboarding and basic analytic skills. And talking about data scientists, they explore and understand the data, and they also access the databases and use the output of pipelines to build by the data engineers. So whatever, so data analysts basically collect the data, extract the data, clean it, pass it to the data engineer. They feed it into the data pipeline, and whatever the output they'll get from that will pass to this data scientist. And for this designated output of pipelines that is built by data engineers, the data scientist, go for this machine learning modeling part whenever you'll get the output from the data engineer. That is the basic differentiation between that, right? And the data scientists basically have the strong analytical skills as well, right? So this is the differentiation. And I also have added one exercise into it where I have given one scenario for that, and I want you guys to look for that between these roles, who are the best fit for data scientist, and who is the best fit for data engineer, and who is the best fit for data analyst position, right? So we'll discuss it till end of session. And yeah, talking about machine learning. So machine learning is basically in a field of study, like where you can say that you will have one kind of data set, and from the data set you have to train the machine. So in simple term, we can say that in this machine learning, there is a different ways to learn a machine, actually to teach a machine, I can say, right? One is present into it in a form of supervised learning. What is supervised learning? So as you can see from this word, like one supervisor is present into it, right? So what is a supervisor? Basically one who present and guide everything in a proper manner, right? So supervised learning is something where we teach the computer that how to differentiate it. And talking about unsupervised learning, where the computer learns from its own, or semi unsupervised or reinforcement learning is something like that, where one agent is present. And you all have played Mario game in your childhood. So what how Mario is normally played, we normally play the game, and in some area actually there could be one porthole into it, and if we jump the character into it, it will die in that area, right? So if I tell a machine learning model to play the Mario game, so if the character will die in a specific area, so the model will get automatically punished, and from the second one it will not, you know mm, it will not go for the same step that he has repeated first time. Because of it, it will remember in that way that I have gone previously there and I have died in that area. Wait, so I'll for the next time will not go for that area, but I will choose for the second path. So that is nothing but this reinforcement learning. And as in supervised, already have explained that we'll have labeled data for that. So what is labeled data? I'll explain you in that way. If we go any kind of vegetable market now, in some store we see that vegetables are spreaded in mixed way. There is no any such as categorization, like for broccolis has been separated or potatoes has been separated. But in some areas, if you go to a mall to buy vegetables now, we can see that there is a proper way where potatoes has been stored in a different way, like for lady's finger has been stored in a different way, and and same for this broccolis has been stored in a different way. So that is how it is labeled. That means it is has been labeled as a potato, and one kind of board is present into it, right? So in supervised learning, we teach the computer that if you will get this shape, so you can consider it as a potato. Okay, so from the next time onwards, if I give the computer a unknown object, so it will look into it, and then it will remember that from the last time I also have given some sort of things and I have labeled it as a potato. So it is matching with this new alien object. So yeah, okay, so I'll just name it as a potato. So this is how it is work for the supervised learning. And for unsupervised learning, what happens? The computer tries to learn from its own. So talking about one example where we have one mall data. Let's example mall data. So in mall data, what happens? Uh, we can say in a way that we have customer data present into one mall. So we can see the person buying iPhone is his spending score is bit high, and their age is bit low. And where the spending scores is bit low but where earning is bit high, that is not possibility to buying iPhone. So the computer will try to make one kind of patterns into it. So they look for if one person that is earning high and if his age is also bit low, like for 20 to 25 years, then the person buying iPhone probability will be bit higher comparing to the person whose might income source is high but of this age is somewhere in between 60 to 65. So probability is bit less in that area. So computer tries to find this pattern in between them, and that will learn by his own. That comes for this unsupervised learning. And apart from that, there is many more terminologies present into it. I'll give you one two example. You can see in that there is computer vision. Computer vision you can relate in that area. We normally use smartphones, and in smartphone you can see that we have one option for object tracking, right? So if we open our camera and we if we on this AI camera, I can say, and if you go to any kind of nearest to any object, it will label them that the mobile will tell you that this could be one bottle, this could be one helmet, or this could be one bag, right? So how they will tell you? Because of in backend it has been labeled for a thousands and thousands of images, like for 2000 to 3000 of images has been labeled as bag. So whenever you see a new image, it will learn from its past that if that object has been marked as a bag, so this new thing could be in similar to that, so I'll mark it as a bad. So that is one in a small example for computer vision. And generative art is something as well. We normally use chat gpt nowadays. So chat gpt, what it does basically, it can generate as well. So if I tell chat gpt to do some work, it will definitely do in that way. But if you use this premium chat gpt, if I tell them that can you make one document for me, and if I'll give them the content, it will create the document for me. So basically it is generating something for me. So that's how this comes under this generative AI. And generative art is basically one kind of things that comes under this. If I tell them to create one images, or you guys might seen some sort of videos that has been created by AI sometimes back, right? So that is something. And clustering is something that I've given example while explaining you this unsupervised learning, that computer tries to cluster these things. Like if we'll get the similar figure, it will cluster in that way. That it is a triangle, then I'll cluster it as a triangle. If that is a circle, I'll mark it, or I'll make a cluster as a circle. If that could be rectangle or something like that, so I'll just cluster in that way. So by getting the new output, new input from any user, it will try to level them based on these past clusters, right? That is how it is. So we'll discuss this machine learning might be in a different course where we'll be learning about machine learning, as it's a huge topic as well, right? So that is something. And going for these domains, so data domains is something that refers to the set of values or attributes that share a common meaning or purposes. So I was discussing with you two guys that domain expertise while teaching you this domain expertise. So domains is something like talking about customer data. So customer domain specifically holds this customer data, and same for this product, same for this employee, for location, finance, it could be anything. And you might have experienced these things, that if you have no query for any credit card for any specific bank, so they will call you, and then we'll discuss that what kind of credit card they can offer and all. So after some days now, you will get a call from different bank that, sir, do you want a credit card or not? So how these things happen, basically it has been stored in customer databases, right? And bank normally sell this data to the different banks, and the different bank will get the data from the older one and then call you based on that. So that has been stored in this customer domain. So from that area, they will pull your details from that. So in different type of domains, the respectively data has been stored in that way, right? So we have this kinds, we have many more, that could be many more domains. So I have added some sort of to explain you in that area. So I hope there is no doubt into it. So I'll jumping to the next one. So that is good data quality measures. So data quality basically stands in three category, that is reliability, scalability, and maintainability. So as this terminology means, reliability is something that refers to the accuracy or consistency of data over time and across different contexts, right? Scalability is something that refers to the ability of a system to handle or increasing the amount of work of data. And maintainability is something refers to that how easily a system can be maintained or updated over time. So this is some sort of parameters you have to keep in mind before working any kind of sector into it. And there are some rules that is present for these data quality measures as well. One is for validity, accuracy, consistency, integrity, timeless, and completeness. So you have to keep in mind for these things before working anything, right? And yeah, talking about database. So is this talking about databases sometimes back that to store any kind of specific data or so database is something that is a collection of data or information. And normally talking about the structural data, we normally use this database management system, that is DBMS, to store data into the database and enable users and applications to interact with the data. So given one practical example, if you are building one web application, or you can say any kind of application into it, and you have one dedicated model that is present into it. So talking about rainfall data into it, right? So in rainfall data, you could have option like for uh, mm, wind pressure and evaporation, sunrise time, sunset time, cloud timings, and amount of rainfall and dates, etc., etc. So that is present into backend, and if I build one machine learning model that defines all of these things, and if I have to get the new output from this system, so I'll build one web application, and into this web application I'll integrate the machine learning models output into the application, and I'll have three options, you can say three different field. So in one field, if I put this, the number of amount of rainfall is, let's example, 6 to 7 and humidity is something this, and what could be relevant factor, let's example, number of rains, number of days, like number of days for rainfall. If I put the value for three corresponding these things, I'll get the output that is there any kind of probability for being flood or not, right? So that comes from these databases where I have my history, I have my actual data stored into this backend, and I can pull using any kind of you know uh, what I can say, any kind of techniques to pull the data. Normally, for pulling structural data, we use SQL. This is structured query language. So we use SQL to pull data from structural databases, right? And we normally work for PostgreSQL and SQL Workbench. These are some sort of tools where to create databases, or that to pull the data from any kind of databases using SQL around. That is basically a database, and these are the examples for databases. So and now we'll talk about data warehouse. So basically, what is the difference between it? So data warehouse is also in a centralized repository where the stored data in a large volume, or in a large amount of data that could be in a form of structured and unstructured as well. So the main differentiation between them is database can hold only structural data, where data warehouse can hold structured and unstructured data as well. And while talking about large amount of data, that data warehouse is only capable of holding this large amount of data into it, right? So you might have heard about this, Reliance Trains, DMart, right? So this kind of companies use data warehouse to store the data into it, right? Then this not possible to store data into databases for those companies because of there are some sort of limitations. If you want to pull data from databases, whatever time it will take to pull from there, data warehouse will give you more flexibility, or more less timings to pull data out to work as a large amount of data. And you can also connect tables or interconnect tables in between to pull the results from that. So given you example, I have two tables. Let's example talking about DMart, right? So I have customer table, I have product table, right? So for any specific customer, if that customer is buying that product, so customer ID is linked with product ID, and same for the different one as well. So if I want to know that which customer has bought which product, and if I also want to know that how much amount the person has paid, so might be the product table could be integrated with sales table as well. Sales table in a sense, I mean how much number of sales that has been present into it, the price could be there into it, right? So if I want to pull this data of data, that is nothing but the metadata, or any specific or detailed information into a large amount of data, that we can use data warehouse for that, right? So data warehouse is nothing but the centralized repository to work for this large amount of data into it. And the major point is also that it basically holds this historical data into it. So database is only capable of storing data for a limited amount of time, but talking about historical data and everything, that data warehouse only is capable of doing that. So that comes for this data warehouses. And most of big companies actually use data warehouse to store their data. It's not only like for DMart or everything, but of like for IBM and some sort of companies as well, to use data warehouse to store data in as a backend, right? So this is something, and we have data collection methodologies for that. So basically we have two types of data collection methodologies. One is for primary data collection and one is for secondary data collection. So primary data collection is a process of gathering data directly from a first-hand source. In other words, you can say it's a data that's collected by the organization that expects to use it. So primary data collection is something, if I tell you in simpler way, uh, if I tell you that you guys can go to your college and then tell me that what are the number of students that is present into class. So you will go there, you will ask someone, or might be you can go to the class directly, and then you'll count them, right? That 1, 2, 3, and then you will come up with that there is a 30 students that is present into the class. So you'll come back to me and then say that in Devjyoti there are 30 students that is present into my class, right? So that is one kind of way to give me the data by using primary data collection methodologies. There is a different kind of methodologies present to perform this primary data collection. One is poll, one is survey, one is statistical methods, one is that could be focus group interviews, that could be anything, right? So there are some sort of these are the some sort of techniques to collect data using this primary data collection methodologies. Talking about secondary data collection methodologies, as this explains, this data information is already available, and the secondary data includes magazines, newspaper, books, journals. So if I tell you to do something, and for that you have to go to a specific area and then to conduct some things, as example for survey or interview, right? That comes for this primary. But if some data is already present into internet or books or magazines, that is something I'm telling you to do, and I will just let's assume if I tell you to get the price of a car or price of a bike that is present. So if I tell you that what is the price of a bike, so go to the Google and search the bike accordingly and come back to me and then say the price of the bike is like for 2 lakhs, let's example, right? So that's come to the secondary data collection methodologies, right? And in industrial sector we normally use this most of in the secondary data collection methodologies, and the techniques comes under this is financial reports, sales reports, government data source, industrial reports, public data set, and commercial data sets, right? So this you don't have to remember exactly that what are the sub things to collect the data, but of only you have to remember that what are the types of or what are the techniques that is available to collect the data. That is nothing but primary data collection, and the second one is secondary data collection. That is what you have to only remember. And talking about Python charts, so we as a data engineer we use a lot of charts in day-to-day life, but you have to get a basic idea about that, why normally use this, when to use this line chart, when to use this histogram and all. So although there is no proper definition, but there is some factors you can remember while plotting graphs in future. One is if you are working for a time series data, or if you want to get the output for a specific time or some sort of things, then you can directly use this line chart, right? And how to plot this line chart, that the code I have been written down, don't have to go through it. It's just a simple code to put the graph into it, that we'll discuss later whenever we'll start for this course for data analytics. As of now you can skip it, but I just wanted to give you overall idea that when normally you do use for these graphs. So line chart is something you can remember by performing any kind of time series or data related that contains this time for a specific industry or specific interval, then you can directly use this line chart, right? And histogram is something to handle this large amount of data set, or which is more than 100 or n number of features present into it. So the main purpose is to show the general distribution of data. So general distribution in a sense that how the data has been distributed over a period of feature, and what could be the feature over the period of time, or over the period of any kind of specific things that has happened. So normally use histogram for that. And we'll definitely discuss for histogram in a better way, because there is a lot of subtopics that is included with histogram. I have to give you the overview for the same, like for standard deviation and variance and all. So quickly give, go to the next slide, that is pie chart. So we normally see pie chart in day-to-day life to bifurcate this, gender wise, that how many number of male candidate, or I can say that how many male candidates is present into this call, and how many of female candidates is present into this call. So you can directly create one pie chart to know for this category. And apart from that, if like for in a specific area, if we want to know that what are the number of students that has scored in between 40 to 60%, and what are the number of students that has been scored from 50 to 80, and what are the number of students that has scored for more than 80% into this exam. So you can also create this pie chart respectively. But one point to remember, try to avoid pie chart as minimum as possible, because of it will not give you a good insight into it. So you can replace them with another graph as well, like taking one example, if you want to bifurcate them for gender specific, then you can use this normal bar chart might be. So in the right side, you can see that there is one category 1 and category 2. Instead of that, you can use this male and female to visually explain that. It will give you better insight than working with pie chart, which is not basically recommended, but definitely you can use it, no problem with that. And stacked bar chart is something normally we use to compare total values among categories. So what I mean by that, let's example, you have 500 bikes present into one showroom, and among that, if you want to know that in specific that time how many bikes has been sold, right? So you can create in that way that this whole things will explain that the number of bikes present into one showroom, and this upper yellow portion will indicate you that this much of bikes has been sold for this particularly number of time, right? And go for the heat map. If we play mobile games or video games, we normally see where we, let's example, you might have played for PUBG or BGMI, right? So when we face this red zone, you can see there is a red point that is marked into this map, right? So that red map is nothing but is called as a heat map. But that is a different scenario that we normally use for the gaming industry. But talking about normal life, we normally use heat map to know that how much one data point is related to another data point. uh, Taking one example, if I have student data set, as I was already giving you example. So if in a student data set, if I have two columns, like for number of sorry study hours, let's example, we have one column named as a study hours, and the next column defines that your exam score. So if your study hours is high, there is a high probability of a getting a better score in exam, right? So you can, if you plot the two things in the heat map, you can see there is a highly correlation between these two factors. So you can see a dark color into the heat map. So if you can follow my cursor, like if you plot here, like for study hours, and if you plot here exam result, then you will have one high color into this area, indicates that these two individual data points is highly correlated with each other. That means if study hours is high, then the exam score might increase. If the study hours is less, then there is a high probability of the person will not score that much in area if the study hours is not that much of high, right? So this is for this Python basic charts that we normally use, and apart from that, we also use a n number of plots that is present into it. But we'll definitely discuss it later. But these are the majorly used charts that is present that we can create by using Python, right? And talking about the next slide, that is market and jobs that is present for the data analyst. So I have plotted one photo for you, that what are the skill set you should have to get a job as a data analyst you have to get a good understanding of data visualization, data cleaning. MATLAB and R and Python are actually, how I can say, either you can choose R or you can choose Python. Both are is it's actually optionable. So my preference is go for Python because of the materials that is present for Python that is bit high comparingly to the R. And in future, if you're working any kind of industry where you have stuck for a particularly problem, the chances of getting help in specific things is bit higher comparingly to the R language if you go for Python. So my recommendation is go for the Python. And there is, you have to know for SQL to pull data from structural databases, and NoSQL also recommended to understand this, to pull data from unstructured way to unstructured databases, right? And machine learning, that is also important for that. Linear algebra and calculus, strong Microsoft Excel skills, critical thinking, communication. So this comes under the soft skills. So you have to get a good soft skill accordingly to work with client and all. And these are the pay scale for data analyst for some organizations. As you can see that these are the range of salaries that is, a company is offering to the freshers as a data analyst, right? So, and this is, by the way, I guess 2023 of charts, right? So yeah, this is something for market and jobs for data analytics. Now I'll just go to one project, right, where I have, just a second. Yeah. So you can see that this is something Jupyter notebook where we normally write our code in Python, right? And if you see that, like I have imported I have imported some libraries, like for whatever that is important to work for. So if I give you idea, that you can see that is written here, import pandas as PD. I'll not go in depth, but I'll give you overall idea. These are some sort of libraries that is used. We normally pull the libraries to work for this upcoming project, right? Or whatever you're going to write down below. So pandas is something that we normally use to perform or to create any dictionary, or to, to play with the data frame, I can say, to play with the data frame. And numpy is something that we normally used in Python to do numerical operations. And matplotlib and c1 are something that we normally use to, go for this, or to create some plots and visualization based on that, right? So you have to import the libraries at very first to work for it. So, and the second column, you can say we have loaded the data set, and to load the data set, you have to follow some basic syntaxes. Dot read is something that you have to read the CSV, what is written inside this CSV. And what is FIFA? FIFA is something that is a data set that contains this FIFA World Cup data for the same, right? So I'm using this dot head function, which normally entails me that this first 5 rows of the data set, what that defines. So I can see the first column indicates the ID of players. Second column indicates the name of players. Age column indicates the age of players, nationality, and overall potential. And you can see there's many more, columns that is present. What is the club value, right? Foot, international reputation, of out of 5. What is the skill, moves, position, joint. So these are the columns that is present. And after that, I have performed some sort of basic statistics for the numerical columns that is present into it. And if I show you now some interesting things, you can see that I have used this histogram for players age. So in the left side, you can see what are the number of players that is present and what are the age. So from this graph, what I conclude that you can see the peak is this. So if we normally, and from here the peak is bit high, so I can consider from this area. So if it is 15 and it is 20, so I can see in between that this could be, 18. And same goes for this, I can say, like for this as well. So So this whole area is bit high. That means most of players are in between from 18 to 36, I can say. You can also say that that could be 34, I guess, 34 as well. That also considerable. But we normally draw conclusion like this. If I create one plot, I have to look into it. That if that is peak, then this is the most number of players that is present for this age, right? So this is something the use of histogram actually into the data. And here is my conclusion that you can see from that above that most of the players are in between 18 to 36 years of age, right? And I can want to see that what are the uh, youngest and oldest player. So how to get this youngest and oldest? So we have age column, and in age column we have different age of players present into it. So I have used dot min function to get the minimum value and dot max function to get the maximum value. So I can see that the age of the youngest player is 16 and the age of oldest player is 45. So here you can able to get the value from that. And I will also have given the statistics for youngest and oldest player. So I'll directly jump to this area part, so that will give you a better idea. Yeah, so this is the distribution of height of players. So I have number of players into this left, and I'll have height for the players. So you can also see that there is a most of height is in between from 5 point something to 6 point something, I can say, right? There are very less players who is having 5 point something height or 6.775 or some similar values for that. So most of players is having height for in between 5.4 to 6.6, I can say, right? This is also the distribution for weight of players, as I have done for height for. So this is the weight for players, and I can see that the most of players are in between 138 to 205 lbs, right? 10138 to 205. Now I have to, if I want to look for what are the statistics of both these players as a most weight and less weight. So also I can see that the lightest player is 11010 lbs, and his name is you know the name is written for the player respectively, and same goes for the heaviest player as well, who is bit fatty, I can say. So now I'll have to check the null data for nationality column, and I can see there is no null values. So again I check for this, and will come up with some sort of graphs where I can see this count of players, and these are the countries. So I can see even you can easily conclude this most nationality of player counts. Yeah, so in above plot, we can see this number of players belonging from 40 countries, and expecting the minimum number of players belong to England and then Germany and then Spain, right? Sorry, I mean to say maximum number of players. I can see this from this chart. From England, it is having more than 1600 plus players that is present. After that, that comes for Germany and then Spain. And I can say that others respectively, number of players that is already you can see from this graph. So that is how. And apart from that, this is his overall score for each Indian player. Oh yeah, so I have tweaked this data set into that way that if I want to see that what are the Indian player that is present into this data set, and I wanted to see that what are the overall score for Indian players. So I have names for Indian players, that is you can see into this name column, and I can see respectively score for that, right? So yeah, so S Chetri, you can say that he is the high scorer for that. So this is something, and this is the average score for players belonging to different countries. One is specific done for India, and this is for mix for that. I mean bifurcated to countries, right? So you can look into this chart, and you can own define that what are the best country to get the average score for football. So this is something we can normally perform ADA. I'm only talking about ADA as of now, because of if we want to go for this each and every lines of code, then that will create a lot of time. So this is something, and whatever the conclusion you will have now, you have to write down below this charts or below this cell, right? So that you will have a clear understanding about that. So here I have plotted for count of players in each club, and this is the count for that. So you can say that on an average, we can say that each club is having 30 to 33 players because of the graphs is in between to 30 to 40. We can say in a stable way. So that's why I have concluded that on an average, we can say the club is having 30 to 33 of players. So if I have to check out the player who has the highest and lowest potential before jumping to this, we'll check for the either we have any duplicate data or not. So there are no null values as it is written 0 here, and we can see that what are the player that is present who has a potential score of 95. That is actually amazing, and they actually deserve for that. Okay, so we have bifurcated them among this potential and all. So this is something we can normally create pool one data set to perform this kind of things, because Python allows you to lot of functions to work for it. Like if I say you to go for this highest score of players, so you don't have to go to mm, write a n number of lines of code to get the value, but Python itself offers you some syntaxes to get the maximum value, minimum value. So this is just example for FIFA data, and you can definitely use it for cricket data as well. And you can also do the different things for multiple data set that is present into it. And there is a lot of platforms that is present at today's time to offer you the data set at free of cost. One of them is Kaggle, and second is Analytics with the, and there is many more that is present. You can directly go to this website and pull any kind of data, and you can pull the data and then look into the data and perform some sort of statistics and area based on that. This is how a data analyst projects actually look like. And I, although I have not included this ML model into it, but if that is actually is an end-to-end project now, so machine learning model will be always at this below point, and we will get the accuracy up to this point, and we'll deploy the model and stop it. Right, this is how it is
There is
worked.
a request.
Yeah, yeah, sure.
Hello. There is a request that all who are joined till now, you have to submit the feedback form, which we will provide, and after that only you will get the certificate. So please, all of you, submit the feedback form at the end of the webinar. Thank you.
Yeah,
You can continue now, sir.
yeah, thanks, Shiva. So yeah, as I already have concluded, so I just want to hear out from you guys that do you have any kind of queries or any specific questions for that? I'll be happy to answer you. If you don't have any question, then I'll just stop sharing my screen.